Welcome to The Explainer. Today, we're going to break down a really big step forward in the world of AI, specifically how we can build models that are not just powerful, but also genuinely private.
So let's just jump right in, because this question gets to a huge tension. A real conflict at the very heart of how all modern AI works.
And that's what we call the privacy paradox of AI. See, to make these models smart and useful, we've got to feed them just unbelievable amounts of information. But, and this is the big but, we absolutely do not want them to just memorize our private data and then, spit it back out for anyone to see.
All right, so for a while now, researchers have had this, like a gold standard theory for how to solve this exact problem. The thing is, it's always come with a pretty massive catch.
That core idea is something called differential privacy, or DP. The best way to think about it is like adding a little bit of static to a recording. By mixing in just the right amount of this mathematical noise while the AI is training, you basically make it impossible to ever know for sure if your specific data was used. It's a clever way to protect individual privacy.
And this slide right here, this really lays out the central problem, the big trade-off. For years, if you wanted to add this awesome privacy protection from differential privacy, you had to pay a steep price. We're talking a huge hit to the model's performance and a massive spike in how much it costs to train the thing. It was a deal breaker, really. It made private AI pretty much impractical on any large scale. So yeah, this performance gap, it was a giant roadblock. But now, some brand new research has finally given us a kind of map, a way to navigate these tricky trade-offs much more effectively.
And this research paper is the key to the whole thing. For the very first time, researchers were able to accurately model that super complex relationship between privacy, performance, and all the insane computation you need. They basically created a predictive formula, a recipe for success.
And this is how they did it, and it's pretty brilliant. They figured out that instead of trying to juggle, a dozen different variables all at once, they could boil the whole problem down to just one key ratio. And that simple change let them create that predictive map we were talking about, a map for finding the absolute sweet spot, the optimal way to train.
And this is it. This is that key variable, the noise-to-batch ratio. It's really just a comparison, right? It compares the amount of that privacy noise they're adding to the size of the data chunks or batches that the model is looking at during training. And let me tell you, getting this one ratio right, that is the secret ingredient. It's what makes the whole thing work efficiently.
Okay, and this discovery led to a really surprising insight. It turns out all the old rules, the standard playbook for training AI, it just doesn't apply here. The recipe for private AI is totally different, and honestly, it's kind of counterintuitive. You don't just use a bigger model. No, you actually use a smaller model, but you feed it data in much, much bigger batches. Wild, right?
So, the theory's cracked, we have the map. The big question now is, what does this actually look like in practice? Well, let's meet the AI model that was built using this exact breakthrough. All right, so armed with this new recipe book, this new set of rules, researchers at Google set out to train the biggest, most capable private model ever built.
And here it is. Say hello to VaultGemma. This is an open model that was designed from the ground up with all these new principles of private AI baked right in. And yeah, it's built at a really significant scale.
We're talking 1 billion parameters. That makes it one of the biggest models ever to be trained completely from scratch with these kinds of strong built-in privacy guarantees. That's a huge deal.
And here's a really important part. They're not keeping this thing under lock and key. Nope. The model weights are being released openly to the entire research community. You can find it on places like Hugging Face and Kaggle. The whole point is to speed up the development of private AI for everybody.
Okay, so we've got this new model. The big question, the one you're probably asking, is how good is it? How well does it actually perform? And maybe more importantly, does all that privacy stuff actually work?
This table right here tells the most important story. When you put it through its paces on a bunch of different benchmarks, the private VaultGemma performs at about the same level as a really powerful, non-private model from about 5 years ago. You might have heard of it, GPT-2.
Now, this comparison is super fascinating. Why? Because it proves there's still a performance gap, right? A private model isn't quite as good as a non-private one of the same size, yet. But, and this is a huge but, for the very first time, we can actually measure that gap. We can put a number on it. And once you can measure something, you can make a real plan to fix it, to close that gap.
So what does this privacy guarantee actually mean in the real world? Well, it offers something called sequence-level privacy. And what that means in practice is that if some private fact about you, say your address, only shows up in one single chunk of the training data, the model basically doesn't know it. It can't use it. Its answers will be statistically the exact same as a model that never even saw that piece of data in the first place.
But look, theory is one thing, right? So the researchers decided to put this to the test, and they came up with a really simple but super powerful experiment to see if it held up.
What they did was pretty clever. They basically fed the model the beginning of a sentence that they knew was in its training data, just to see if it would try to auto-complete the rest of it from memory. You know, like when your phone tries to finish your text message? A non-private model would probably do that.
And the result? It was crystal clear. VaultGemma did not regurgitate its training data. It didn't complete the sentence, which is awesome. It proves that the differential privacy was working exactly like it was supposed to.
So what's the big takeaway from all this? Look, VaultGemma isn't the end of the road. That performance gap we talked about, it's still real. But this is a massive, quantifiable step in the right direction. Why? Because it proves the roadmap, the recipe. It actually works.
This research gives us the tools, and it shows that they're effective. So it leaves us with one final, pretty exciting question, right? Now that we actually have the map, how fast can we close that gap and get to a future with fully private AI? A future where AI works for us without ever working against our privacy.